So previously till here we have discussed all about the quadratic equations like AX, what is the general form of a quadratic equation, like what we have discussed we will see what we have discussed. We have discussed general form, general form of quadratic equation. We have discussed the general form of a quadratic equation. We have also discussed what are the graphical way of representation. We have discussed graphical way of representing quadratic equation. So graphical way of representing the quadratic equation we have discussed, and whatever we have discussed. Uh, so till here we have discussed. So the general form of quadratic equation, what does that equation represents, and also we are going to start how to find the solution, and also we have known the solution, how to find a solution from graphical way, solution finding, right? Solution finding from graph. So this solution is nothing but called as roots of the quadratic equation. So the solution is called as the roots of the quadratic equation, or can call as the solution of the quadratic equation or roots of the quadratic equation. So how we will get the solution? Ax square plus bx plus c equal to 0. If we equate this with 0, we will get the solutions. Okay. So we have discussed previously. We have three methods. What are that? Formula based method, square method, and factor method. So one by one we will see. First today we will see about the formula based method. So formula based method we will see first today. Formula based method. What does this formula based method? Directly see, you tell me, if any coefficient it has power of 2, it will have two solutions. Quadratic equation will have two solutions. See, it may happen that solution number 1 or root 1 and root 2 are the solutions. It may be possible that root 1 may be equal to root 2, that is only 0 may be only solution, 0 comma 0 may be a solution, or minus 1 comma minus 1 can also be solution. But the number of solutions, that is number of solutions, number of solutions of quadratic equation, number of solutions of the quadratic equation is 2. So that is the thing. Okay. Solutions may be equal, like solution 1 is 0, or solution 2 can also be 0, but what should be taken? But the number of solutions of a quadratic equation must be 2. So solution 1 and solution 2, in the formula based method what we will do is, see, root 1 root 1 is equals to one formula, and root 2 or solution 1 or root 1 is one formula, or solution 2 or root 2 is other formula. Directly we will substitute all the values of a, b and c in those formulas and find directly the root 1 and root 2. No need of doing some other things. So this is a formula based method. So let us see. So see, this is what roots means. What does the root means? See, a real number alpha is called a root of the quadratic equation ax square plus bx plus c equal to 0, such that a not equal to 0. If a alpha square plus b alpha square plus c equal to 0, what does that mean? Suppose x, we know that ax square plus bx plus c, ax square plus bx plus c is equals to 0, it is there. In this, suppose x is equals to alpha is a solution. I mean, x is equal to alpha is a solution means what? Is a solution. What does x equal to alpha is a solution mean? If you put alpha in this equation, it will satisfy. Means a alpha square plus b alpha plus c equal to 0. So if this will become true when x equal to alpha is a solution, or vice versa. If a alpha square plus b alpha plus c equal to 0, then x equal to alpha is a solution, or if x equal to alpha is a solution, then we call a alpha square plus b alpha square b alpha equal to c. So now suppose we will assume we'll take one equation, okay? What equation we'll take? X square, like let us assume a equal to 1, b equal to 1, c equal to 1. If you put in this equation, what does it happen? What does it happen? A x square plus bx plus c equal to 0. Now put a equal to 1, b equal to c equal to 1. 1 into x square plus 1 into x plus 1 equal to c. So it will become x square plus x plus 1 equal to c. So this is an equation number 1. Suppose let us assume a condition will satisfy this equation. Any condition will satisfy this equation. Suppose let us assume whether x equal to 1 satisfy this equation. Substitute in that one. If check whether we will check whether x equal to 1 is a solution or not. So how we will check whether this is a solution or not? This method. If x equal to alpha is a solution to this equation, if you substitute that value in this equation, it must be equal to 0. So let us check. If you substitute this x equal to 1 in this equation, what will happen? 1 square plus 1 plus 1 equal to 0. So 1 plus 1 plus 1 equal to 0. So 3 equal to 0. Does 3 equal to 0? No, this is false. So hence x is equals to 1 is not a solution. Or I'll take one more page. So where we are, ax square plus bx plus c equal to 0. Substitute a equal to 1, b equal to 1, c equal to 1. Then we'll get x square plus x plus c. Okay, plus c is 1, right? X plus x square plus x1 equal to 0. Now what we are checking x equal to 1 is a solution or not, right? Is a solution or not? So how we will check whether x equal to 1 is a solution or not? Just to substitute that value. If it is satisfied that equation, then it is a solution of that equation. So if we substitute, what we'll get? 1 square plus 1 equal to 0. What is 1 square? 1 plus 1 plus 1 equal to 0. So 3 equal to 0. Does 3 equal to 0? No, 3 is not equal to 0. As 3 is not equal to 0, x equal to 1 is not a solution. Not a solution of x square plus x plus 1 equal to 0. Okay, so did you get understood? If any value of x is a solution to this quadratic equation, then if you substitute that value in this equation, it must satisfy this equation. Okay, so we are having one example, x square plus x plus 1 equal to 0. So using the formula method, we will find what is the value of this x square plus x plus 1 equal to 0. We will find the roots or solution to that equation. See, so if see what is given, if alpha is a root of ax square plus bx plus c equal to 0, then we say that x equal to alpha satisfy the equation ax square plus bx plus c. If x equal to alpha is a solution of the equation ax square plus bx plus c equals 0, yeah, the roots of the quadratic equation ax square plus bx plus c equal to 0 are called as zeros of the polynomial ax square plus bx square plus c. So this is important. What is important? So roots, we can call it as roots or solution or zeros of polynomial. What is a polynomial? Ax square plus bx plus c equal to 0. This is called polynomial of degree 2. And when we equate with zeros of this one, we will get the roots or solution or roots. So any of the things are correct. So roots of the quadratic equation or solution of the quadratic equation or zeros of the polynomial, we can call them. That is the thing I have been mentioned. Okay, in the next thing is more examples of quadratic equation we will see. So like now see, we will find the this one we will find. I'm not forgetting that we have to find the solution of this x square plus x square plus x plus 1 equal to 0. I'm not forgetting. We will use the formula method to find the value of the roots. Two roots will be there, right? For a quadratic equation we have two solutions. uh, for the two solutions we will find the two solutions, and we will also check whether if we substitute the values of that roots in the given equation, it must satisfy. So we will verify whether those roots are correct of the correct solution or not. Also we will verify. Okay, so first of all we will see the examples, how to proceed with the problem solving. Suppose 2x square plus 5x plus 3 equal to 0 is given here, right? Now we have to compare with this general form. What is this equation in general form? Ax square plus bx plus c equal to 0. Can you compare? Can you compare these two equations? Means what is the coefficient of x square here? A. So coefficient of x square in this equation is a. What is the coefficient of x square in this equation? It is 2. So if we are to compare this one, a equal to 2 will say, if a equal to 2, this and this equation will be same. Similarly, what is the coefficient of x here? It is b. What is the coefficient of x here? It is 5. If b equal to 5, these both are same. What is the coefficient of x power 0? C. What is the coefficient of x power 0 here? 3. So by comparing these two equations, we will get the coefficients a equal to 2, b equal to 5, c equal to 3. So this thing is important. Comparing the quadratic equation. Suppose if the problem is not in the general form of quadratic equation, we have to bring that into a general form of quadratic equation of ax square plus bx plus c equal to 0. And then what we have to do, next step is comparison of the coefficients. Okay, we have to compare the coefficients. We have to compare the coefficients. See, another example is what it is giving. What it has given. Okay, 1 minute. I will clear this all. See, what is the other equation given here? X square minus 3x equal to 0. It is there, right? So we will take this one. X square minus 3x, x square minus 3x equal to 0. Now you tell me x square minus 3x equal to 0. Does this in the standard form? What is the standard form? Ax square plus bx plus c equal to 0. This is a standard form. So what we have to do? We have to compare these equations. What we'll compare? We'll compare the coefficient of x square in this equation standard form, and we'll compare coefficient of x square in that given equation. This is given equation. So by comparing these two equations, coefficient of, see, I'm just writing for your convenience. Later you don't need to require all these things. Just you will write, say, coefficient of x square a is equals to, in this coefficient of x square is a, and here coefficient of x square is 1, right? 1. And what about the coefficient of comparing the coefficients of x? In this coefficient of x is b. So b is compared with coefficient of x is minus 3. This is, so b is equals to minus 3. And what about the coefficient of x power 0? Coefficient of, this is x power 1. This x power 0 is nothing but c. C into x power 0. So okay, now so is there any coefficient here? Only coefficient of x power 0 is 0 because there is no constant term here. If there is a constant term, suppose if there is an equation of 3 x square minus 3x plus 10 or plus 9, then this will become a constant. But in this given equation there is no constant. So what will take? C equal to 0. Hmm? See, this is the first time you are understanding, so that is the reason why I am writing coefficient of x square is nothing but a, that is equal to 1. Next time you don't write this coefficient of x square, coefficient of x power 1, coefficient of x power 0. This is just for your understanding. Your brain should function by comparing the coefficient of x square in both the standard form and the given equation. This is for the first time, so that is why I am writing. Means you have to compare the standard form and the that form. Okay. Next is a equal to 1. So by comparing we'll get a equal to 1, b equal to minus 3, and c equal to 0. Next time you don't need to write this one. You have to start your problem by a equal to 1, b equal to minus 3, and c equal to 0, right? Okay, so that is the thing. Okay, so next, okay, this is all about the comparison of the things, right? So see here, see, this is a little more tricky, right? Where a is fact 1 by comparing a equal to 1, right? 1 into x power 0. And what about b is equals to minus 3, right? X coefficient of x is minus 3. And what about the c? There is no constant as c equal to 0. So same thing he has shown as, so x is because c is not shown, there is no constant term in that equation. What about the 5x minus 3 equal to 0? So let us take 5x minus 3, he also given 5x minus 3 equal to 0, he has given. First of all, you tell me whether 5x minus 3 is a quadratic equation or a linear equation. What is the degree of this equation? What is the degree, you tell me? What is the degree of that equation? 5x, I'll write once again. 5x minus 3 equal to 0. What is the degree? How you will find the degree? maximum power of variable. What is the variable x? What is the maximum power of that variable? 1. So the degree equal to 1. So what are those equations when degree equal to 1 are called linear equations? So this is not a quadratic equation, not a quadratic equation. Okay, so this is not at all a quadratic equation, this is a linear equation. So this is not a quadratic equation because it is missing x square term, because this is a degree 2, right? It has a degree 2, because this is only degree 1. This has only degree equal to 1. In the other words, a equal to 0. But the condition of a quadratic equation is a should not be equal to 0 is a condition of quadratic equation. That means it can't be quadratic. That's the thing. Okay, that it is just a comparison. Comparison. First thing is comparison of equations in standard form. Means if any problem they have given, first of all, first thing you have to do is step 1. You have to convert the given equation into standard form. So you have to convert your equations into a standard form. What is the standard form? Ax square plus bx plus c with one side, other side equal to 0. So in that form you have to compare, I mean you have to convert that your given equation in this form, and then you have to compare the both the equations to get a value. A equal to how much you have to get, b equal to compare b, what is the coefficient of x, b you have to find, and what is c you have to, by comparison you have to tell. So that is the step. See, this is a hidden quadratic equation. So far you have seen the standard form of a quadratic equations, ax square plus bx plus c equal to 0. But sometimes a quadratic equation does not look like that. So here are the examples. So we'll take the one example and we will see what is the first example is given. X square is equals to 3x minus 1 is the example he has been given, right? X square equal to 3x minus 1. So we'll do it here. X square is equals to 3x minus 1. Now you tell me, friends, students, whether this equation is in the standard form, or which form this equation is in standard form. No, this is not in standard form. In standard form, one side will be completely 0, right? 0 will be equated with the expression. So we will bring all items to one side. So it will become x square minus 3x plus 1 equal to 0. We are sending this 3x to this side and minus 1 to this side. The signs will get reversed, right? If it change from one side to other side, the signs of the equation variables or the constants will get reversed. So it will become x square minus 3x plus 1 equal to 0. So one side we got 0 and other side we got polynomial with degree 2, sorry, degree 2. Okay, hence this is in the standard form. What is the standard form? Ax square plus bx plus c equal to 0. So we'll compare that one. Minus 3x plus 1 equal to 0. So by comparing the coefficients, so what will be by comparing the coefficients? A equal to 1, and these two equations we have to compare. What is the coefficient of x square, what is the coefficient of x, and what is the coefficient of x power 0. So by comparing, what we'll get? A equal to 1, and here b equal to minus 3, and here c equal to 1, c equal to 1. Let us check what is the standard form. Ax square plus bx plus c equal to 0. If we substitute again these values, we will get this equation. Let us see. A equal to 1, put 1 into x square plus b is minus 3 into x plus c is 1 equal to 0. So it is 1 into x is x square minus 3x plus 1 equal to 0. So we got the original equation, given equation. Hence these are correct. Comparison, our comparison is correct. So like this we have to first of all convert the given equation into the form, and that then we have to proceed with the problem. Okay, so what is given? So here also he told the same thing. move all the terms to the left hand side, like x square minus 3x plus 1 equal to 0. By comparing with it with the standard form, we will get a equal to 1, b equal to minus 3, and c equal to 1. So we will see another equation he has given. 2 into w square minus 2w is equals to 5. Okay, this is a thing given. So whether this equation is in standard form, you tell me. Hmm? It is a quadratic equation because the maximum power of what is the degree of that one? Degree of w. Okay, first thing, what is a variable here? What is a variable? Variable is w, right? Variable is w. And what is the degree? What is the degree means? What is the maximum power that a w has? 2, right? Degree 2. Hence this is a quadratic equation, but not in general form. But not in general form. Hence you have to convert this into a general form. Convert. Not in general form. You have to convert it into general form. How you will convert? First of all, you expand this one. 2w square minus 2 into 2w equal to 5. I what I did, distributing 2 into w square and 2 into minus into 2w. So it will become 2w square minus 2 into 2 4w is equals to 5. It becomes 5. That is the thing. And in a quadratic equation of standard form, one side should be completely 0. So subtract minus 5 on both sides, minus 5 here and minus 5 here. It will become 2w square minus 4w minus 5 is equals to 0. So hence this is in the standard form. Oh sorry, you are not able to see, right? So I'll write here, or I'll remove this one. Okay, what is the equation? Once again we will do it. 2w square minus 4w minus 5 is equals to 0. We got, I mean, how we got this is 2w square minus 2w, I mean 2w square minus 2w equal to 5. It is there. So we'll split this. 2w square minus 2 into 2w is equals to 5. So this is not in standard form, because standard form 0 will be on the one side. So substituting subtracting minus 5 on both sides, we'll get 2w square minus 2 to the 4w minus 5 is equals to 0. So this is in the standard form. So we'll compare this with ax square plus bx plus c equal to 0. So we will get, by comparing, what we'll get? Coefficient of okay, sorry, coefficient of power 2, degree 2 term coefficient, a equal to 2, here b equal to minus 4 and c equal to minus 5. Is it true? Correct? Did you get a equal to minus 2, a equal to 2, coefficient of w is minus 4, coefficient of x power w power 0 is minus 5, minus 4 minus 5. Hence like this we have to compare. Okay, next, z into z minus 1 equal to 3 he has given. Okay, again we'll blank screen. So what he has given, z into z minus 1 is equals to 3. That is the thing he has given here. This problem, z into z minus 1 equal to 3. Now how you will do that one? How you will do that one? Z into z minus 1 is equals to 3. We will simplify it. Z into z, z square, minus z into minus 1 is minus z is equals to 3. So we need 0 this side, right? One side we need 0, so minus 3 on both sides. So z square minus z minus 3 is equals to 0. This is in the standard form. Ax square minus plus bx plus c equal to 0 is a standard form. So by comparing, what you will get? A equal to 1, b equal to minus 1, c equal to minus 3. See, this is constant term, minus 3. This is minus 1 and this is 1. That's the thing. So this is how we have to compare the coefficients, right? Okay, that is all about the comparison, how to compare the coefficients. And one more difficult thing it is given. This one we will see. 5 plus 1 by x minus 1 by x square equal to 0. Okay, we'll see that one. What is that he has given? 5 plus 1 by x minus 1 by x square equal to 0 he has given. What does be okay, Okay, now actually what we need an ax square plus bx plus p we need. But what does he has given? 5 plus 1 by x minus 1 by x square is given. So it is very difficult. So we'll take LCM better. Okay, we'll take LCM. Take LCM like this of equations, because we need x square term on numerator but not on denominator. But the x square term is on denominator. So let's take LCM. Let's take LCM. You know LCM how to do? So here, what is the LCM? Here for 5, divide and divide x square is LCM. By seeing x square is LCM, so divide x square and x square into 5 plus here x by x into 1 by x minus 1 by x square equal to 0. That is LCM. Divide and x to get numerator as x square, you have to divide x square and x square, x and x. Okay. Next is what we'll get? 5x square plus x minus 1 by x square equal to 0. So see, we'll assume that x is not equal to 0. If x is not equal to 0, we'll assume x is not equal to 0. Then x square plus x minus 1 equal to 0. This will become equal to 0. If x is not equal to 0, then this numerator will not be equal to 0. If x equal to 0, this will become 0. So it will be undefined. Something by 0 will be undefined. Something by 0 will be undefined. So we'll assume that if we'll assume that x is not equal to 0 only. So how we'll assume? 5x square plus x minus 1 by x square equal to 0. So this, if this is not equal to 0, how this total should be, how, when it will be equal to 0? It will happen only when numerator equal to 0. Hence 5x square plus x minus 1 equal to 0 is the thing. So by comparing, this is in the standard form. By comparing it with the ax square plus bx plus c equal to 0, you only tell what you will get. A equal to 5, b equal to coefficient of x 1, and c equal to minus 1. Yes, this is about the comparison. See, why I'm taking why I'm focusing on maintaining, bringing it to standard form is, we already see that we will use formula method. We'll we already seen that we use formula method. In formula method, we will use the standard form as the reference, ax square plus bx plus c. This as reference we will take reference, and then using the values of a, b and c, we will derive formula for x1 and we will derive formula for x2. That is the reason why any equation they have given, first you have to bring that into a standard form, and then from this equation you have to compare with this standard form and find out the values of a, b and c. If you know a, b and c values, then these values should be substituted in some formula. We will discuss in the next thing. Further we will discuss. There we have to substitute this a, b, c and values. Then you will get x value and y value. I mean x value, x1 value and y2 value. So these three values are important to substitute in the formula of x1 and y2. Hence, if you substitute that, we will get the roots or solution or zeros of the polynomial. Zeros of polynomial. Okay. So this is all about a comparison. In the next class, if you are perfect, we will see some examples in the next class, and then we will go to the formula. What is the formula? Then you can easily, if you convert any equation into the standard form and you get the a values, b values and c values, then it will be very much easy to get just substituting the values in the formula and get the roots or solutions of that equation. Okay, that is the thing.